So here we're going to finish off this plant. For this one, we're mainly going to focus on essentially having our spines unroll as our stem unrolls. So they're going to kind of spring out as this rolls down the length of the stem. We are going to create a second set of normals that run along our stem, and then we can use that mask we created earlier that was used for actually unrolling our joint chain. So the mask we created way back up here, and that is what's controlling this unroll. And we're going to use that to blend between our two vectors, which will allow us to blend our spines between the two positions. So let's just set that up a second. I'm going to come up here, I'm going to hold shift just to drag everything above up here a bit more. Let's rearrange things a little. So at the moment we've got our sweep, we've got normals on that, we've randomized that, normalized that, we've created our up vector, and we have scattered that onto our points. Instead of using these normals, let's create an alternative branch over here, which is going to give us normals that run along our spline. So if we come to our resample here, let's put down an orientation along the curve, connect that one up, and this is going to straight away give us normals that run all the way along the tangent of our spline. Now we could use attribute transfer to transfer these ones onto our geometry here. So let's just do that with attribute transfer. Now the geometry to transfer the attributes to is our geometry here. Let's also move this up a bit more so we have a bit more space. 1 second. The attributes we're going to transfer from, that's going to be our curve normals here. So let's connect that one up. If we select that, we're going to not transfer any primitives, and we're just going to transfer our normal attribute here. So now we have our geometry with these normals copied onto it. Let's just connect up this and this so the attribute transfer is now kind of the root of what we're scattering onto. And if we go down to our copy to points, you can see we now have our spines all lined up like this, which is going to be our sort of start position. So instead of overriding our normal position here, let's actually store this normal as a different attribute. If we come to our normal, we can change this, instead of being normal, to, let's call it N2, so normal 2. It's just going to be a second normal that we're going to blend between. We're going to attribute randomize that normal 2 as well. We basically need to do everything we've done in this whole stack to our N2 point now. So let's do the same here, N2, N2. And we've got an error. And this actually brings up a good point. So Houdini, I'm sure some of you know that if it's using an attribute that it knows about, for example, normal, it will automatically realize that this is a vector. If you create a vex attribute like this that Houdini doesn't know about, so Houdini doesn't know what N2 is because I've just made it up myself, if you don't put anything before this attribute sign here, it's going to assume it's a float, and you can't normalize a float, and also it's going to break our setup. So we need to specify that this is a vector, so we're going to type v at N2 and v at N2. And it's actually lucky that this happened, because if we didn't have the normalize here that was going to error it out, we would carry on forward using N2 as a float. And this is actually the reason why I always put my prefixes here in vex, because so many times when I didn't do this, I would do this by accident. Something breaks at the end of your scene and you have no idea where it's gone wrong. So if you always specify what type of attribute this is, it does save you headaches later on down the line. Okay, so this is now normalizing our vector normal 2, and then we are creating our attribute up, so that's fine. So now here on our attribute transfer, we have got both our normal and our normal 2. So we can now actually mix between these two. Let's come down here. Let's just select our copy to points again, and turn off our vector normal visualizer thing. And let's just put down a point wrangle. And let's just call this one mix. And here we're going to use a new function that's super useful. We use it all the time. It's called lerp, so L-E-R-P. And this is just basically a mix function, and it allows you to blend between two values. So we're going to set our normal, let's do v at n, equals lerp, L-E-R-P. And it basically needs one value, your second value, and then a mix amount. And it could be a float, this can be vectors. You need to mix the same type, obviously, but you can use it on any kind of data type. So we're going to mix between our normal. Let's put the v in here just to give us good habit. V at n2. So we're going to mix between our normal and our normal 2. And let's just create a channel float slider for the moment, just called mix. Just to demonstrate this, I'm going to create that. And if we now blend between these, you can see we get a really nice blend essentially between these two vectors. So it's allowing these spines to sort of open up. So rather than using this mix function here, we're going to delete this, and we're going to use that mask that we set up earlier that ran through our spline to control this. Now we don't have that mask at the moment on our geometry here. And the reason for that was when we set this up way back at the start with our rig wrangle, we were just doing this on a variable, not an attribute. So we never saved this mask outside of our wrangle. So I'm going to create this as an attribute. Let's just come, I'm actually going to do it before the smooth and after the clamp. So let's type float attribute mask equals mask. So it's going to store the mask at this point after it's been clamped. It's then going to carry on and smooth it and use that for the rotation, but our mask has actually been stored as an attribute at this point. And this is now going to get carried on all the way down to the bottom to our mix. And in fact it hasn't, so I'm sure there's something we've missed up here. Let's think, oh, we did attribute delete because we cleaned all our attributes off. So we also need to come up here. It's just off the screen, but let's take our mask and let's just add this little caret up arrow sign, which will mean don't delete that. So now at the bottom here, we should have our mask as well. Okay, so let's create this here. Let's do mask. In fact, it's float attribute mask, of course. Let's delete our old mix. I'm going to right click on it, come to more, delete spare parameter, and just delete that. Let's just see if this works. And it is working, but it's actually working backwards. So they're all spread out at the start and then they're coming together at the end. So we're going to remap this now. And probably for this, because it's just an attribute that goes between 0 and 1, I'm just going to just do a channel remap. Let's in fact just make a variable for this called float, call it mix. And it's going to be equal to channel ramp. We'll call this remap normal, or remap normals. And we're going to use float attribute mask. And then just use that mix attribute we just created as our mix. So if we create this, it's going to create a little spline we can adjust. Currently this is exactly the same, but we can now flip this. And now we get sort of the desired effect. I'm just going to shrink this value in. I'm going to need to remap this slightly, I think. See if I drag this down now. And in fact, I'm also going to select both of these and set this to be monotone cubic, my favorite fall off. And then we can now sort of adjust this a bit more artistically to see how we want this to work. It's a little bit hard to see because at the moment they're all so long still, but hopefully you get the idea that as they're still folded up, they're all sort of in one line, and then as it comes out, they will spread apart. So like this. Okay, so let's now do the same thing, but we need to do the same for our P-scale. So as it unrolls, we're going to have these grow on. This is actually pretty simple. We're just going to take our mix again, and we're just going to apply that to our P-scale. So let's put down float attribute P-scale equals use another channel ramp. Let's call this one remap p-scale. And again, we're just going to use float attribute mask. It's going to create values between 0 and 1. This is actually all I really want for this. So let's create that. And you can see we are now, again, this is backwards, so let's flip that. Come down to our remap p-scale, just press this button to flip it. And we have them essentially unrolling like this. And again, this is nice and sort of intuitive now. We can just take these and sort of remap it as we wish. Bring this in to make it a bit more contrasty. Going to give it some fall off again, monotone cubic. Let's just sort of play with this a little bit more to get sort of like the look we like. Quite like having a little bit of this sort of thing unfolding from the start. In fact, maybe even a little bit more. Let's just have a look in there. Bring this up. Bring this one in. I think something like that. Cool. I'm also just wondering as well, perhaps maybe this might look better if instead of using the mask before we smoothed it at the start, maybe if we go back up to the top, maybe if we take the smooth result and use that. So I'm just going to Control X to cut that out. I'm going to paste it after we've smoothed it. So now we're assigning the mask to the attribute after we've smoothed the result. And I don't know if this is going to make any difference. Probably, if anything, I'm going to think it is, but it's not really going to. I think there's difference. I'm going to keep it in. Okay, so we're going to go for that. So we're going to use the smooth result and install that as the attribute, which we're then going to use to essentially grow on our p-scale and the mix in our normals. Okay, cool. So we're almost there. I think as well, I want to just now, obviously at the end now, there's no movement. So I'm going to randomize our normals a little bit, which is going to give us a little bit of movement just as it's sort of coming to a rest. So I'm going to use a attribute noise. Let's drop that down there. I'm going to randomize our normal. I'm going to make it, let's see, let's do 0 centered. I'm going to add the noise. So this is kind of adding our noise to our normal. Let's just go for about 1 for now. I'm going to make the element size much smaller so you can see it's adding a lot more sort of fine detail in there. I'm also going to come down to our fractal and reduce our roughness. Roughness adds like an extra level of sort of grit to your noise, but I often just bring it down to 0 because I want quite a smooth sort of result here. Okay, so let's just fine tune this a bit more. Let's see. That's looking quite nice now. Let's bring down our element size to maybe, let's go 0.5. Let's bring down our amplitude to about 1.1-ish. I'm going to animate this as well. So animate noise. Pulse duration is kind of the speed. If you set it to a low value, it's kind of super fast. If you set it longer, it gets slower. So I'm going to go for something maybe around 6, maybe 5.5-ish. I think something like that. And I might also just, let's see, let's take a section where it's opened up. Because we've added this noise, it's kind of changed the look slightly. So I might just perhaps change the offset of this noise. Let's come to X, Y, and Z and just shift it in one axis. Sometimes it's a bit easier to control that way. Just trying to find something that I like. Seems to be quite hard to do at the moment. Let me see. Perhaps if we had a bit more amplitude. Don't want us to go too crazy. I don't really like all this down here, so maybe we bring it back again. Maybe about 0.9. Something like those values, and let's just see how that looks. think that's quite nice. Still feel like there's a bit of crossover in this. Let's see. I do like having more amplitude in here, but at the same time I don't like this crossover quite so much, so maybe I just need to shift the noise a bit more. See how that looks. Increase the element size. Sometimes I feel like I'm just making it worse at this point. Let's just see. Yeah, I think it was better before. Let's go back to 0.5. I think it was 1.1. And let's finally just shift this noise one more time, see if we can get that something I like a little bit better. Thing like that is pretty cool. Okay, nice. I'm also going to add a bit of randomization to our P scale as well. So I think this will also help once we're getting to the final step here. So let's put down a, let's use attribute adjust this time. Just another way of adjusting our attributes. Attribute adjust float. Let's put this one down here. We do want to adjust our P scale. I'm going to use noise once again. I'm going to multiply this and I'm going to use a min and max value. So let's first bring down our element size under the noise pattern. This is going to just change the overall size of our noise. So you've got something super small here. I think sort of something around this level is quite nice. Keep it big at the end. I'm going to raise the minimum value to be about 0.5-ish, I think. So you just have it sort of going in and out as it goes across the curve. Again, I'm going to adjust our noise and I'm just going to shift this a little bit so it's more like this. I think maybe just bring down our element size a little bit more. Yeah, something like that. Move it along. Sometimes this stuff is the most fiddly bit I find. I quite like that. I think this is what we're going to go for. It's got a nice sort of like bit at the end and it's got a bit of variation in between. So let's have a look at that one. Now you can also maybe see that the noise of our P scale is actually shrinking. Effectively our points are moving through space and the noise is being shifted as it's moving through that. So essentially our noise is being controlled by our location attribute P. Now because that's moving, it's giving us sort of a bit of jitter in our P scale here. Now instead of using P, we could actually fix this to what's called the rest attribute. If we go back up to the top here where we had our points initially, these weren't moving at this point. So we could put down a rest attribute here, or rest position. Now the rest position doesn't do that much at all, except it just copies the current state of your position into a rest attribute called rest. And the good thing about this is now you can continue having your points moving, but the rest is stored at this state. So if we come down now to our P scale, we could change our location attribute. Instead of P, we can change it to rest. It's essentially like sticking the noise to your moving geometry. So if we have this now, you can see that our P scale is staying static and it's not shifting around. Now we've also got that on attribute noise as well, but I think because it's all moving, it's actually adding a nice bit of sort of movement to it anyway. So I'm going to keep that as it is. So let's just finish up and see what else we have to do here. I'm going to drop down merge to merge this with our original stem. So let's go back up to the top here where we did our sweep. Let's grab that one and let's just merge that in. So you've got those two together. I am going to maybe just clear out our attributes. It's a bit hard to see on this small screen, but we've got a bunch of attributes here that we're probably not going to use. Things like our source prim and our source prim UV. For now, I think I'm going to get rid of all of these. And if we do need them later, we can add them back in. So let's just put down an attrib delete. Let's just clear out everything here. We will get rid of our color, but never mind. We're not going to use that for the final render anyway. So there we go. Now, one more thing I want to do is probably have this as well scale up from the start, so it's not just there from the beginning. So let's put down a transform. I'm going to come to about frame 60, I think, maybe a bit earlier, maybe about frame 50. Keyframe the scale, go back to frame 1 and just keyframe the scale back to 0 here. Shift click on that, and let's just bring out those handles a bit, as always. So now it kind of unrolls a bit like this, and we get that. I'm liking that. So the last thing I might just change looking at it now is, obviously this is our Z axis, and I might just align the tip of our stem here just to be lined up with completely with the X axis, because it's a little bit off center at the moment now. If we go back up to the top here, come to our curve, enable our tool again. Just going to bring this down just a little bit like that, so it's more in line with the center. Maybe grab this one and just drag it up a little bit. That's our resampled curve now. It's a little bit more lined up to the center. And if we come to the bottom, in fact, we need to, before we do that, we need to come to our skeleton, because we need to restash this. So KineFX needs to reload the geometry to update. But that really is the beauty of KineFX, is you just restash it and already it's rebuilt the entire joint chain. And of course, all your animation is going to work. I love it. I can't think of any other 3D program that can do that. So it's super cool. Let's come down to the bottom, have a look again, turn off our KineFX and just press play, see what we've got now. And we've now introduced a problem, and I'm pretty sure I know what this is. I'm glad it actually came up, because this is something, it's a good thing to know about. So when we moved that, we seem to have slightly twisted the geometry with our rig setup here. So as it unrolls, I think we're slightly messing with our sweep. So the point is, sweep will generate a normal and an up to generate kind of like the direction of our sweep geometry itself. If I put down an orient along curve, we can probably see this. At the moment, by default, it's set to have a normal along the tangent and the y-axis is up, and the y-axis is currently set to the curve normal. So if I turn on our normals here, and I also turn on our up, make sure that's enabled. Not sure why, half the time you have to select and reselect this. Okay, so if we look at this as it unfolds, I expect, yeah, it flips at the end. So essentially it's trying its best to figure out what's the up vector based on this unrolling curve, but it's not always able to make the best decision. And because it's using curve normal, that's essentially the problem. Instead of using this curve normal, let's come and change this to be x-axis. It's pretty much the same. We're just going to fix it to go along our x-axis here. And now you can see it's not going to flip. And because we've now set these attributes specifically with orient along curve, when we come to our sweep and turn off these visualizers, you should see there's no flipping on our curve. So it's nice and straight. Come to the end, play again, and hopefully that's now fixed it all. Nice. Okay, so let's just put down a null. Let's call this one plant B underscore out. And we are going to move on next lesson.